Hello everyone. So for this lecture, we will be having the design of a singly reinforced T-beams. Okay, and also we will discuss its balance condition. Okay, so in this problem, the T-beam shown is resulted from a monolithic construction of the beam and the slab. Okay, so kailan ba mangyayari na we should consider the beam as T-beam? Okay, so according to the code, if monolithic yung construction, kumbaga sabay yung buhos natin sa ating beam and the slab, pwede tayong gumamit ng beam flange or kumbaga pwede tayong gumamit ng tulong sa ating slab. Okay? Kasi pag monolithic yung pouring ng ating concrete, pwedeng mag-isa. Parang naging composite yung action nila. Okay? Kaya magkakaroon tayo ng flange dito sa itaas. And sa code, may binigay na minimum beam flange na gagamitin natin. Okay? Minimum beam flange. Kumbaga, naka-specify sa code iyan. Okay? So, this one, ito lang yon yung statement dito. And I have the material strength, Fy, ayan. Then, I just put it here in MathCAD. And by the way, I will use here the MathCAD software, okay? Para mas madali sa akin yung discussion. Okay, kasi mahaba yung solutions dito. Now, we have the floor dead load 15 kilonewtons per meter and the floor live load 20 kilonewtons per meter. And take note that floor dead load is hindi pa kasama yung beam dyan. Okay, yung floor lang yan, including this slab. Okay, so we have the length of the beam as 6 meters. So I just put all the datas here. Okay, for part 1, calculate the balance steel ratio. Okay, so unlike sa rectangular cross-section, we can use that formula, the row balance here. Hindi. We should calculate it manually. So, uunahin ko yung C balance. Okay? We can use the C balance kahit anong section because this is derived sa ating strain diagram. Okay, using the C balance formula, that is 600 times D, okay, times D over 600 plus Fy. Okay, so by the way, I will just put units here, okay, because para hindi siya mag-error. Sa calculator nyo, wala na yung MPa. Okay, so please take note. So, I can calculate the C balance and ito yun. Okay, then I will calculate the A balance. So, just follow the step, A balance. And that is, take note, that is beta 1 times, of course, that should be C balance. Na ano yung beta 1 natin? Okay, by the way, beta 1 should be, here is 0.85. Okay, that is because our FC prime, which is 21 MPa, is lesser than 28 MPa. Okay, so take note of that. May code akong pinakita dito on our previous lecture. Okay, so by this, we can calculate our balance A. That one. So after this, take note that our A balance, lumagpas siya sa ating H or the thickness of the slab. So by looking at this figure, and by the way, no, the effective depth pala natin is 520 millimeters. That is just 520 minus 70 mm. This one. Okay? Now, ito yung mangyayari. Ito yung A balance natin and lumagpas siya sa ating thickness. Now, if we will do the stress diagrams or force diagrams, it will be like this. Okay? Ito yung A balance natin. Lumagpas siya. And of course, ito yung stress distribution ng ating concrete. And here, since may overhanging flange dito, gagawin ko is hahatiin ko yung forces ng ating concrete. Okay? So, this is our tension and hahatiin ko yung concrete natin para mas madali nating illocate yung ating forces pag nag-moment na tayo. Okay? Ito yung centroid ng ating flange dito. Overhanging flange ito, by the way. Let me call this as CF. It will be acting at this centroid. Then, ito yung for the web, let me call that as C sub web, C sub W, or the compression concrete of the web. And of course, it will be acting to this one. Okay, so ito yung magiging itsura niyan. Now, I will just equate that one. The CF and CW is equals to T. That is for us to calculate the AS of the steel. Okay, after we can calculate the AS, then we can use na the balance, the steel ratio formula, AS over BWD. Okay, so this one, by equating C is equals to tension, and by the way, our C is composed of CF plus CW. Okay, so in this case, I will just define first C is equals to 0.85 FC prime. Okay, mga variables yung gagamitin ko dito ha. Na-define ko na ito lahat. Okay, so just follow lang. FC prime times ano yung area natin. Okay, take note, ito yung total area ng ating concrete. So, uunahin ko yung sa flange, no? CF. I will just factor out the stress na lang, okay? I will just factor out the stress. Uunahin ko itong stress or force sa CF. So, the area for the flange is beam flange. Then, of course, tatanggalin natin to, this one. Okay? Minus beam width, that one. Then, i-multiply ko siya by the thickness para maging area. And of course, plus this area of this web. That is just beam W, or beam width, times the area balance, since we are here in balance condition. Okay, klaro? And ito yung ating C, total compression of the concrete, and that is newtons yung lalabas dyan. I will just convert this one to kilonewtons. Okay? Para mas maikli yung ating force. Okay? So, don't be confused with this, ha? I-diretso nyo na sa calculator nyo. But ito, gagawin ko dito is define ko para mas step by step ko. Okay? And please, take note sa units. Ito is auto-generated units to. Okay? So, take note that newtons dapat yung gagamitin dito. Then, if we have C, then I will just use this one. Take note that T is ASFY. Okay? For balance condition, Fs is equals to Fy. Gagamitin natin. So, our AS balance here is just equals to the compression, that one, this whole term here, compression divided by Fy. Okay? I hope you get this one. Ito, this whole term. Since may value na ako dito, I can just automatically solve that one. mm². Okay, klaro? That is the AS balance. Now, to calculate the required balance steel ratio, then I will just do this one. Row balance is equals to AS balance divided by BW times ating effective depth. Okay? And that is the balance steel ratio. Ito. Okay? Klaro? I will just put 6 decimas. Okay? That one. Ito yung answer natin sa part 1. Okay? That is the answer. Now, for part 2, yung hinahanap is the ano ba yun? Design moment, balance moment, design balance moment capacity. Okay, so if we are to find the design balance moment capacity of the beam, then we can use these values. Okay, but take note, mas maiging, ito yun. If we will look at this drawing, this is our nominal balance moment. Okay, so we need to consider this one. That is just the effective depth minus half ng H. And ito, that is just the effective depth minus half ng AB. Of course, this will be acting at the centroid and also that one. Okay, mas dito ako mag-moment sa T in the line of the action of the T para mas madali. You can take moment about this point, but baliktad na yung forces niya, magma-minus ka pa. And it can cause confusion. So, ito yung pinaka the best option. mag-moment tayo sa T to calculate the nominal balance of the beam. So in this case, talagang i-isolate natin yung CF and CW since iba-iba yung moment arms natin. Okay? So, ang general equation natin here, dito, M and B is just equals to CF, that one, times the moment arm na D minus half ng H, 0.5 of H. Okay? Then, plus the CW times the moment arm na D minus 0.5 of A. That one. Okay? Then, I will just define first the CF and the CW natin para mas maikli yung solution ko dito. Okay, CF, unahin ko yung CF, that is 0.85 of FC prime. This is just the stress times the area. Okay, ano yung area ng overhanging flange natin? Again, that is just beam flange minus beam W, beam width. So, ito yung matitirang net width nila. Okay, tatanggalin natin to. Then, i-multiply natin by H. And ito yung force FC prime. Okay, mag-error siya pag hindi correct yung ating units. Okay, let me just put it in newtons na lang. Okay, naka-newtons tayo. Then, CW, that is the same, 0.85 FC prime. Ano yung area natin? So, in this case, the area for the web, that is beam width plus A sa B. So, beam width, multiply A sa B. And that is in newtons. Okay, klaro? Then, I will just substitute that one all to here. Okay, so, our M and B is equals to CF times D minus 0.5 of H. That one. Plus CW times D minus 0.5 of course, dito, that should be a balance. Okay, so we are considering the balance condition dito. Okay, ilagay ko lang dito, a balance. Klaro? So, our M and B, or the nominal balance moment, is just equals to kilonewtons meters. So, by the way, ang lalabas sa calculator nyo dito is naka-newtons millimeter. Dito, diretso na siya. Okay, wala bang error? Let me just check. Okay. Okay, so I think correct naman lahat. No? Now, ano yung design moment? Design balance moment. Take note, we should account the reduction factor. Ano yung magiging reduction factor natin? Okay, so we are using Nscp 2015, so we should use this one. Or yung table. Pinakita ko yun on our first lecture. Okay, so here, since we are considering balance condition, Fs, or the actual stress, is equals to Fy. And that will correspond to the reduction factor as 0.65. Okay, this is for balance. Just follow this one. So, our reduction factor for balance is 0.65. Okay, therefore, the design balance capacity is just equals to phi M and B. And that is the answer for this one. Okay? Gets nyo? Okay, so that one. Capital natin para highlighted talaga. Now, for part 3, we are to design the ating area of steel bar. Design na tayo. So, ano yung gagawin natin? Of course, we have the loads. We should calculate first the ating what do we call this? Ating load. I mean, the ultimate moment or the factored moment, rather. Okay? A design of of area of steel bar. Okay, that one. So I will just first calculate the total load. Take note that this is floor dead load. So I will first calculate the total dead load. Let me call that WD lang. Okay, So here, yung dead load natin dito is floor load. I input it dito sa MATCAD. WD sub F. Okay? So the total floor load is just equals to that one, the floor dead load for floor, then plus, okay, take note, kilonewtons meter dapat yung unit natin dito. So how to calculate the cross-sectional area dito? I mean the dead load additional due to this beam. So that should be gamma of concrete. I will just denote this one, gamma of concrete times the area. Okay, so in this case, this is floor dead load. That should be including this slab. Okay, kasali na to. So, ang i-add natin dito is itong nasa ibaba lang. Okay, so the area of this one, that is beam width or BW times the depth up here up to here lang, that is the total depth D minus ano yung i-minus natin, minus H. Okay, so by the way, hindi ko pa na-define yung gamma of concrete. So for the purpose of demonstrating lang, I will just use gamma of concrete is equals to 24 kilonewtons per cubic meters. Okay, yan yung gagamitin ko. And by the way, hindi ko pa rin na-define yung D pala. I will just define the D dito. Okay, the total depth of the beam. That is 590 mm. Okay, para hindi mag-error yung MATCAD natin. Okay, hahanapin niya kasi yung value. Okay, that one. So the total dead load that will be in kilonewtons per meter. Okay, dapat ganito yung unit natin. And of course, we have the live load here. So by using the basic load combination 1.2 of W dead load plus 1.6 of W live load, ito yung factored load natin. Okay, then since this is simply supported beam, the maximum positive moment or positive moment lang talaga, mu is equals to, okay, recall this one, basic formula, no, to calculate the maximum moment for simply supported beam. So ito yung factored moment natin. Okay, klaro? Now, anong gagawin natin? Ibang type of solution ito compare sa rectangle. Okay, so ang gagawin ko, we are not still assured if yung A natin or the effective depth of the concrete is o lumagpas ba siya sa beam width dito or andito lang sa flange natin. So what will I do is I will check the capacity of the flange. Okay, tingnan nyo na lang. Okay, look at this one. I will calculate the capacity of the flange. This is the total flange, okay? Hindi yung overhanging flange. The total flange. I will just calculate MNF or VMNF, then I will compare to this one. Ito yung magiging determinant natin if lumagpas yung A natin sa web or hindi. Okay? So, that will be MNF. F is equals to, as you can see, CF of the flange times the moment arm D minus 0.5 of H natin. Okay? That one. Now, ano yung CF natin dito? So, our CF here is the total the total force acting on the flange. Okay? So, that will be idiretso ko na lang siguro. MNF is equals to stress of the concrete FC prime times yung area ng concrete dito. That should be BF, beam flange, times the H. Okay? Then, I will just put the moment arm D minus 0.5 of our H. That one. So, ito yung magiging MNF natin in kilonewtons meters. Okay? Now, I need to compare the design. So, we should account the reduction factor. And by the way, for design, kung gagamitin natin yung epsilon T, okay? Let me just do this one. Our boundary to be used natin dito is I will use epsilon T is 0.005. Okay? That is for us to determine if this is singly or doubly. Then, of course, our reduction factor in this case should be 0.05. Okay? So our phi m and phi n m f, m and f, okay? Multiply by m and f is equals to, ito yung design for our flange capacity. So why did we calculate this one? So okay, so we calculate this one in order for us to know if that one, yung A natin, that is for us to determine if yung A lumagpas sa flange. Now as you can see, mu is lesser than m and f. Okay? Gets nyo? Okay, I will just put it here. mu, okay, mu is lesser than this one. Kung ito yung case, that means hindi na natin needed yung beam width natin dito. Okay? Andito lang yung concrete na gagamitin natin. So, yung A natin, yung case dito, okay? Case should be, no, our case that is A is lesser than H. Okay, klaro? Hindi lalagpas yung A natin dito. Okay, so by the way pala, sa design of a T-beam, napaka-rare lang na maging doble ito. Okay, because of this flange of the concrete. Masyadong malaki yung compression natin because of the flange. Okay, so in this case, to calculate the area, ito yung step natin. Okay, since we know that A is lesser than H because of this one, ito yung magiging actual compression natin. Okay, ito lang yung mga forces. Pag lumagpas ito, that means may ibang force pa dito. Hahatiin natin. Okay, so this one, so we have the mu. I will just equate mu equals to the compression times d minus 0.5 of A. And hahanapin natin yung A una dito. Okay? So take note that I will just say that my given equation is just equals to mu is equals to, ano yung C natin? That is 0.85 FC prime. Then, ano yung area ng ating concrete? That is beam flange times A. Of course, no? Beam flange times the A, by the way. Ito yung A natin dito. Okay? Effective depth of concrete. Hindi siya lalagpas. Then, the moment arm, ano yung moment arm? The same dyan. Times D minus 0.5 of A. D minus 0.5 of A. That one. So, you can just do shift solve here. Okay, may mu tayo. We have these values here. Yung A, yung unknown. So, by doing that shift solve, so in the MathCAD, I will just assume a value muna, 100 mm, let's say, since I know that it is lesser than. Okay? Parang nag-guess ka lang sa calcu dito. So, in your calculator, if you have shift solve, here in MathCAD, I will have here, find the value of A. No. Okay? A yung variable ko dito. So, I press equal. So, ito yung A ko dito. Okay? Klaro ba? That one. Ito yung A natin. So, after I got the value of A, I can equate the compression and tension. Okay? That is for me to calculate the AS. C is equals to T. Okay. So, by that, equating, take note that C is equals to 0.85 FC prime times that one, the area of this, is equals to AS Fy. So, our AS here, AS is equals to 0.85 FC prime times the area of the concrete, the beam flange, times the A natin. Okay, we have the value of A here. Then, i-divide ko siya by Fy. That one. Okay, klaro? Ito lang yun. Itong C is equals to T. Then, cross-multiply natin yung Fy. Then, ito yung magiging value ng ating AS. That one. Okay? So, is this the answer na for our design? Okay, so we need to check the AS minimum first. That one. Okay, according to the code, AS minimum shall be the greater of A and B. So, pinakita ko na to. But for T-beams, for statically determinate beams with a flange in tension, the value of BW shall be BF times 2BW. Okay? So, in this case, take note that gagamitin natin to if yung FC prime natin hindi lumagpas sa ating 31.36. Okay? So, remember that. FC prime is lesser than 31.36 MPa, then we will use this one. Okay, so unlike sa rectangular beam, we calculated the rho minimum. Dito, diretso na tayo sa AS minimum for T-beams. Kasi magmamatter sa ating BWD, yung ating AS minimum. Okay? So, at is stated here, pag ating flange daw is may tension, the value of BW is BF or 2BW. Kumbaga, i-substitute natin dito. So, medyo nagkakalito, no? So, ang gagawin ko is I will just compare. Okay. Ang BF natin is 100 and 2BW times 340, that is 680. Then, we will use the 2BW. Okay? Kasi lesser value. Okay? I hope that is clear. So, here, I will calculate the AS minimum. AS minimum. And by the way, no, gagamitin pala natin to if yung flange natin, the flange ng ating beam, will be having a tension. Okay, kailan siya magkakaroon ng tension? If yung C natin or the effective neutral axis natin is andito sa itaas. So, let me check muna if we will use this one, this code provision ito. Okay, our C, take note that we have the value of A, that is A over beta 1. And that is 29 millimeters approximately. That means andito siya sa beam flange. Because the portion below the C natin, that is in tension. That means we have a tension on our flange. Okay? So that means our AS minimum is just equals to, just follow this formula since lesser yung FC prime natin sa 31.36. So, 1.4. I will just put unit here over Fy. Okay, so, kailangan ko ng unit dito para hindi siya mag-error sa MATCAD. Okay, times BWD. And take note, I will substitute BWD here as 2 times BW. Okay, gets? Times D. Okay, because of this statement here, 2BW. Okay, and that is 1192. Okay, now as you can see, mas maliit yung ating AS sa ating AS minimum. Hindi ba tayo nagkamali dito? Okay, let me check ha. Dito tayo. MU, dapat may reduction factor pala ito. Okay? May reduction factor. MU, dapat equate natin sa design. May reduction factor dapat. That one. Okay, nagkamali ako dito. Okay, sorry. So, mag-iiba yung value ng A natin dito. Okay, because of that reduction factor. Okay, the same lang solution. The reduction factor lang yung nakalimutan ko. Okay? So, ito yung magiging AS natin. And yung AS natin is greater than AS minimum. Okay, so ano pa yung i-check natin? I-check natin if this is singly or doubly reinforced. So, I will just use this strain, no? Since we are using the boundary as 0.005, then I will just calculate the strain. Okay, so take note that we can calculate our FS, actual stress natin on this steel. Okay, hindi ito yung ginagamit natin sa design. Ito yung actual. That is 600. Okay, remember the formula. D minus C divided by C. Okay, again, may unit ako dito para hindi mag-error. And that is MPa. Okay. Now, take note, yung i-compare ko is yung strain. Okay, pwede natin ito i-compare actually sa 1000 MPa. But for you, na hindi kayo malito, I'll just calculate this strain. That is strain T. Okay? The actual strain for tension, that is Fs divided by Es. Okay? And by the way, the Es for the steel is 200 GPa or 200,000 MPa. So we have the value of the strain, actual strain. Ito. Okay, that is the value. Now, as you can see, epsilon T is greater than yung ating boundary na 0.005. That means this is okay. This is singly. Okay? That is designed for singly. Pag bumaba dito sa ating boundary, that is doble na. Okay? But napaka-rare ng condition na yan na maging doble for T-beams. Believe me, no? Hindi talaga magdodoble pag reasonable lang yung values ng ating loads. Okay? Always yan or rarely na magdodoble talaga. So, our AS is ito. Ito yung magiging answer natin. Correct. Na-check natin yung AS minimum and na-check natin yung strain, which is ito yung main consideration sa code. So, our AS is that one. Okay? I hope you get this. This is the answer. Capital lang. Okay? Gets na? Now, what if palalakihin ko yung moment? Okay, so this is my additional problem ha? Okay, look at this one. Gagawin kong 1,000 kilonewtons meter. Okay, additional problem. Additional, bakit hindi additional? MU what if gawin natin yung MU as equals to 1,000 kilonewtons meter. Okay. Now, again, i-compare. If we will compare this to the M and F, saan ba yun? Na-compute natin yung kanina. The capacity of the flange. Ito. Phi M and F. Okay. Just follow, ha? That one. As you can see, our MU exceeds this one. Phi M and F. No? Nag-exceed na siya. That means, we are needing this beam width na dito. Lalagpas na yung A sa ating H. That means our A should be greater than the thickness of this slab. Okay? Check ko lang sa first. Okay. Ito yung case natin kanina. Then, pag lumagpas yung ating MU sa ating Phi M and F, then the case will be like this. A is greater than H natin. Okay? Klaro? So, magiging ganito yung stress diagram natin. We will be considering this one. Ito yung A natin. So, by that, again, I will equate the moment sa ating total moment dito. Since ito, isa-isa naman to, or I just isolated the flange, overhanging flange, and the web, ito yung equate natin sa MU natin. Okay? So, I will just define, let's say, MU. Again, MU dito is 1,000 is equals to, of course, may reduction factor dapat. Okay? So, reduction factor phi times CF, ito. Okay? We will just equate M and F equals to CF times that one, and that one, and that one. Okay? But may reduction factor yan. Times the moment arm D minus 0.5 of H plus, again, the steel reduction factor phi times CW times D minus 0.5 of A. Okay, so again, yung A yung hahanapin natin dito, una. Okay, so let me just define the CF. CF is equals to 0.5 85 FC prime, and this guy, in this scenario, yung CF natin is just the overhanging flange lang. Okay? Overhanging flange. So, the area of the overhanging flange is just beam flange minus beam width multiplied by the thickness. Okay? Of course, tatanggalin natin to. Ito yung CF natin. And that is in newtons. Okay? Klaro? That one. Then, my CW, okay, just like what we did kanina, I will just do this as a function of A. Okay? Please don't misunderstand this one, ha? This is not a multiply. That is a function of A, since A yung hahanapin ko. So, 0.85 FC prime, then, the area. Ano yung area for the web? That is, of course, yung A, which is yung hahanapin natin, multiply ko siya by the beam width. That one. Okay? Klaro ba? Okay? Don't misinterpret this one, ha? That is a function. Para, I will just substitute that one dito, then automatic na siya makuha sa MATCAD. Okay? Sa inyo, manual talaga yung gagawin nyo. Okay? For me, I am discussing the principle here, so I don't need to do that manually. Okay? Please understand this one. So, again, ibabalik ko dito yon. MU, let's say this is my given equation. Given. Okay, so MU is equals to, ito, the same lang dito lahat. Okay, I'll just copy this one. But, take note, I let CW as a function of A. Again, don't misinterpret this one. Okay? So, again, you can do shift solve, and I can do here, I will assume value of A that is greater than H. Let me say 130 millimeters. Okay? By doing shift solve, I will find the value of A, and that is 131. Napakaliit lang. No? Lumagpas siya. Pero konting value lang. 131. Ay, hindi pala. 120 pala yung H natin. Okay, lumagpas talaga siya. Now, after this, we can calculate the AS dito. Okay, so again, just equate C is equals to tension. And that C is composed of CF and ating CW. Okay? So, let me just say that that is CF plus CW. Okay? Equals to tension. That one. Okay? And since we have the value of A, we can directly solve that. And take note, T is equals to AS FY. And idiretso ko na lang, ha? AS is equals to this one, the whole compression of the concrete. And again, I will just say that the CW is a function of A. Para automatic na siya mag-substitute dito lahat. Okay? I hope you can understand this one. Then, divide ko siya by FY lahat. Okay? Dapat maintindihan nyo to, ha? Then, our AS here, in this case, needed is that one. Now, the question is this the answer? Okay, so i-check pa natin. Of course, lumagpas talaga siya sa ating, what do we call this? Sa minimum, no? Lumagpas, of course, pinalakihan natin yung moment, mas lalaki yung ating area. Okay, ano yung minimum natin? Ito, this is our minimum. Okay? And our, i-check pa natin if this is singly or doubly. Okay? And by the way, I will just put the AS minimum dito. This is greater than, no, AS minimum. Okay, ito yung value ng AS minimum. Okay. So, that is greater than. So, okay yan. Asan ba yan? Okay. So, if that is greater than the AS minimum, then, pumasa siya. Then, ang i-check na lang natin if lumagpas ba siya sa ating strain. Now take note, we have the value of A here. So I will calculate again the C by A divided by beta 1. Okay? And actually, we can just use pala the AS natin, yung for tension control. Pwede ganon. But since I introduced you this one, ito na lang. Okay, so let me erase this one. Ito na lang. I-compare natin siya sa AST natin. The same principle lang siya. Okay, you can just compare this one to AST or compare natin siya sa strain. Dito na lang yung AST. So I will just calculate the rho T natin. Okay, if you remember. Hindi pala. We cannot use this one because this is for rectangular cross section. Okay, so I hope hindi kayo nalilito, no? Again, I will just calculate the C, and that is A over beta 1 mm. That one. After I will calculate the C, I will calculate the actual stress. Ano yung formula? 600 MPa and D minus C divided by C, and that is MPa. Okay? So, by this pa lang, I can say na this is singly kasi lumagpas siya sa 1000 MPa. But to follow the step, I will calculate the epsilon T. Epsilon T is equals to Fs divided by Es. That is okay. So as you can see, our epsilon T, that one, is greater than 0.005. Okay, that means this is for singly lang. Hindi talaga siya for doubly. Okay, so therefore, our AS is that one. Correct yung AS natin nakuha. That is the answer. Okay, so I hope you understand this one. And that's it.